Hi, today we're going to talk about axis intercepts and graphs of quadratic functions. So, an important property of quadratic functions are the axis intercepts. And there are two types of axis intercepts that you can have. You can have an x-intercept, which is the graph, which is where the graph crosses the x-axis, which are located by the green points here on the graph that I'm drawing. And those are denoted by x comma 0 if they are in coordinate point form, because the y value of an x-intercept is always 0. And then the next type of axis intercept that we have is what we call the y-intercept, which is the value of y where the graph meets the y-axis, or the location in which the graph crosses the y-axis, which is in orange here. And the general form of a y-intercept is 0 comma y, because the x value of a y-intercept is always 0. So another thing that I want to bring out right now is that we have the property of this parabola. And remember, the equation of a parabola is given by the form y is equal to ax squared plus bx plus c. Okay? Anytime you have that, you need to understand that the value of a is going to determine whether the graph goes up or goes down. So when a is greater than 0, then that means the parabola opens up. If a is less than 0, then the parabola is going to open down. So basically, if a is positive, it opens up. If a is negative, it opens downward. So the next thing we're going to talk about is finding intercepts. So the x value of any y-intercept is 0. To find the y-intercept, you need to substitute in 0 for x and then solve the value for y. So remember, anytime you have an y-intercept, the x value is 0. So we're going to have 0 comma y. So that tells us that x goes in for 0. So if we have for question A on example 1, we're going to have y is equal to 3 times 0 squared minus 7 times 0 plus 4. And we all should know that that is equal to just 4. So the y-intercept written as a point will be 0, 4. That will be the y-intercept. If we look at question B, we want to plug in 0 for x and solve for y. So we're going to have f of 0 is equal to 4 times 0 minus 2 squared. And when we simplify that, we will have 4 times negative 2 squared. And we already know that negative 2 squared is 4, and 4 times 4 is 16. So if we were to represent this as a point, it will be 0, 16. All right. Now, if we look at example 2, when it's talking about the x-intercept, it says, to find the x-intercept, you substitute in 0 for y and solve for x. So you can do this by factoring the quadratic formula. You can do it by completing the square. You can do it by graphing. We're going to use the graphing calculator. If you want to do it by factoring or completing the square or the quadratic formula, I can show you that separately. But we're going to use our calculator, being that our test is calculator active. So for example number 2, it says find the x-intercepts of question A. Says f of x is equal to 2 times 4x minus 3 times 7 minus x. So what we're going to do is we're going to go to y equals and we're going to type that in. So 2 times 4x minus 3 times 7 minus x. And we're going to graph it. Because remember, anytime you find the x-intercepts, you're going to put in 0 for y and you're going to solve for x. So basically that means we want to find our x-intercept. So that is going to be the 0. So when we do that, we know that f of x, which is y equals we know we're going to put that as 0, and we're going to set it equal to 2 times 4x minus 3 times 7 minus x. And when we do that, when we go back to y equals, we can put in the 0 in for the y2, because remember, when you're solving an equation, you can put the left side in y1 and the right side in y2, or vice versa, and then see where they intersect. So when I graph it, I see my two colors pop up, and now I want to see the intersection of those two. So I'm going to press second trace, and then I'm going to go to number 5, and I'm going to get as close to the intersection as possible. And then I'm going to press enter 3 times. So here I have an x-intercept that is at 3/4. And I also repeat the process, and I will have an x-intercept at, let's see, get as close as possible. Let's see. We're going to have it approximately at, and I'm still scrolling, this one is going to be at 7/0. So I have x is equal to 3/4 and 7. And if I write those as coordinate points, it would be 3/4, 0, and it would be 7/0 if I wrote them as coordinate points. So those are my two x-intercepts. Another way that you can do it is if you want to, instead of putting the left side of the equation of y1 and the right side of the equation of y2, we can do part B in the other way. So part B, it says y is equal to 10x squared minus x minus 2. So if we place that, then what will end up happening is we can see where the graph touches the x-axis. So what you can do is you can press second trace, and remember, x-intercepts is a synonym for zeros. So we can press number 2 for 0. So we see that the x-intercept on the left-hand side, if I go to the left side of the x-axis, is going to be on top of it. So I press enter. And then I want to go to the right side of the x-axis, and then I press enter. And as you can see, the x-intercept is going to be in between those two dotted lines that show up. And then I press enter again. So here I have negative 0.4. And negative 0.4 as a fraction is negative 4/10, which simplifies to negative 2/5. And then I also have another one. If I press second trace again and go to number 2, I want to go to the left side of the one on the right, which means I'm going to be under the x-axis, which means y is going to be negative. So I press enter there. And then I go to the right side on the other side of the x-axis and press enter. And then I press enter again, and I see that I have 0.5. So that's telling me that my x-intercepts is either going to be negative 2/5 or positive 1/2. So if I wrote those as points, I would have negative 2/5, comma 0, and I would have 1/2, comma 0. All right, so that's how you find your x-intercepts. All right, so if we look at example number 3, it says that we want to sketch the graph of y is equal to x squared minus 2x minus 8 from the value of a and the axis intercepts. So remember, the value of a tells you whether your graph should be going up or down. So we see that the value of a here, a is equal to 1 because that's a 1x squared there. So because a is equal to 1, we already know that this is going to be going upwards when it opens up. All right, so we know it's going to open upward. And then we can find our x-intercept. So I'm going to use the calculator. So I'm going to put y equals. I'm going to type in x squared minus 2x minus 8. And then I'm going to graph it. Okay, and then I'm going to go to second trace, and I'm going to go to 0, and I need to go to the left side, which is going to be on top of the left intercept. So I go to the left and press enter, then I go over to the right and press enter again. So I have 1x intercept is at -2, and then I'm going to find the other one. So I go to the left side of the one on the right, which means I want to be under the x-axis. Press enter. Then I want to go to the other side on the right side and press enter. Press enter again, and I end up getting 4. So my x-intercepts are located at -2, 0, and at 4, 0. So if I go to -2, 0, and 4, 0, I'm going to plot those. And then, of course, you can find other points that you can plot as well by going to the table. So I'm going to go to second table. Okay. And when I go to second table, I know that the y-intercept is going to be the value of y when x is 0. So my y-intercept, just by looking at the table, is going to be -8. And we write that as a point as 0, -8. So when I plot that one, that is what I get there. And then you can always look at the table and plot other points as well. So I'm going to plot the other points. So I know that when x is -1, y is -5. So I'm going to plot that point. I see that when x is -3, y is 7. So I have a point here. I can go the other way when I see that x is 1. When x is 1, I end up getting -9 for y. I also see that when x is 2, I get -8. When x is 3, I get -5. We already have 4, 0, and we need 5, 7, which is the point right here. And then remember, you always want to connect it with a smooth curve, and we already know and we can see that this is going to open upward, because when I connect them, that is the shape that I get. And remember, it does not have to be perfect at all. That's what the points are for. All right. So that is what the parabola will look like. If you have any questions, please let me know, and will be happy enough to assist you. Have a great day.